Well, what an inspiring morning. My own work centers on psycholinguistics. Psycholinguistics is a field at the intersection of psychology and language and linguistics, and it looks at the interaction between mind and language. Most of us know that the mind can produce language, can comprehend language, but it turns out that the languages we speak also shape our minds and shape the ways we think. So today I'll go over some of the recent discoveries in the psycholinguistics of bilingualism and multilingualism. And I've just recently synthesized all this work, the past 25 years, into a book called The Power of Language. It's available out, and I'll be signing copies after that. It's also available online in Mandarin, different versions, the Taiwanese and the Chinese version. As many of you know, there are over 7,000 languages spoken in the world today. But what you may not know is that the majority of research continues to be done on only a very small proportion of these languages. And only speakers of what are known as weird languages, coming from weird nations, are really well represented in research. And weird stands from Western, educated, industrialized, rich, and democratic. This is a very small proportion of the world, but it's the majority of the work on which, of the research on which we build our knowledge. Not only that, but the majority of research is done on monolinguals, predominantly English, and again, Western, educated, industrialized, rich, and democratic nation speakers who speak usually Germanic or Romance languages. Doing the research on monolinguals does not represent the reality that the majority of the world population is bilingual or multilingual. It is very common in countries all over the world for children to grow up with 2 or more languages from an early age, and then later acquire additional languages later in life. Europe keeps very accurate data on that, which is why I'm showing some of the numbers from Europe, where you can see that there are countries where the majority, into the 90% of speakers, are bilingual or multilingual. But that's true everywhere in the world. Singapore has multiple official languages, India, Canada, just about anywhere you look, the majority of the world is bilingual or multilingual. Even in the United States, where historically we thought of this as a one-language nation, the proportion of bilinguals and multilinguals is rapidly growing. Already more than 1/5 of American households speaks a language other than English at home, and that doesn't account for households where bilinguals and multilinguals are present, but English continues to be spoken. So what happens when the majority of the world is bilingual or multilingual, but the majority of research is done on monolinguals? Well, what you end up having is not only an incomplete, but really an inaccurate understanding of human cognition, human mind, and human potential. You can think about the field of medicine as a parallel, for example, where up until just a few decades ago, the majority of research was being done on white men. And we now know, for example, that heart disease manifests differently in women. Diabetes manifests differently in populations indigenous to North and South America. So if you only do research on white men, you don't really understand the etiology, the treatments, you don't really get the full picture of heart disease or diabetes. In the same way, if you only look at monolingual minds, monolingual brains, monolingual everything, you don't really understand human cognition and human mind. So for the past 24 years at Northwestern, we've been running studies with speakers of many different languages using lots of methods and looking at how learning another language changes the way people function in multiple domains. And before I talk about consequences of bilingualism and multilingualism, I'd like to tell you a little bit about how bilinguals process language. Understanding how the mind of bilinguals and multilinguals works will help you understand the foundation of all the changes we see as a result of bilingualism and multilingualism. So this is the work that sort of set us on this path and started this research on the consequences of bilingualism and multilingualism. So how do bilinguals process language? Historically, people thought that when bilinguals process a language, they turn off the other languages. So as I'm speaking to you now in English, all the other languages that I know, I turned off. I'm not using them. When I'm done with English, I switch it off and I switch to my other languages and use those other languages. But it turns out not to be the case. So once new research methods became available, like brain imaging, eye tracking, we've been able to measure whether another language is being processed even when it's not actively used. So for example, in this experiment, we would have Russian-English bilinguals sit in front of a desk, real desk, moving objects around while we track their eye movements. And we would tell them things like, pick up the marker, put the marker above the glasses. Now pick up the glasses, put the glasses to the right of the cross, and just have them move objects around. What they didn't know is that in some of the trials, there was one item on the display, the name of which overlapped across languages in onset. So here, the Russian word for stamp is marka. We have Russian-English bilinguals, they only listen to English, Russian is never used, and we tell them, pick up the marker. And what we find is that Russian-English bilinguals make eye movements to the stamp, and this happened in a fraction of milliseconds. They are not aware they are doing this. More than twice as often than monolinguals do, and more than twice as often than they look at any other objects in the display, suggesting that as language comes in, the input gets mapped onto all the languages a bilingual and eventually multilingual knows until the final selection is made. So bilinguals don't actually turn off their other language. Their languages are being co-activated and processed in parallel at all times. And this, let me show you another way to look at co-activation of language in the bilingual and multilingual mind, sort of similar paradigm, again, eye tracking study, but in this case, the words don't overlap in any language. But what happens is their translations in the other language overlap. So this was done with Spanish-English bilinguals, and in Spanish, the word duck and the word shovel overlap, pato and pala. Spanish is never spoken, we're doing all in English, and we tell them, click on the duck, move the duck, above the cheese. And what we find is that Spanish-English bilinguals are more likely to make eye movements to the shovel when they hear the word duck than people who don't speak Spanish, or than these bilinguals are to any other object in the display. Again, suggesting that not only does the language you hear gets mapped onto all the languages you know, but the translations of the words that you hear are co-activated in the mind as well. And this has now been done with lots of different languages. Here are just some examples in labs around the world. Not all studies in science are always replicated and robust, but in this particular case, this is replicated. So we know that bilinguals and multilinguals process all their languages in parallel in this highly interactive fashion. You can think of the brain as this parallel processing superorganism. And one way to visually represent this is to think of, for example, a word, like just a three-letter word like pot in English. If you speak English, multiple meanings of this word are activated. A cooking container, a sum of bets, an herb, a planting container, and a container, and depending on which word you're more familiar with, the activation is stronger versus weaker. But not only that, but related words that share some form or meaning are activated in the monolingual English mind. However, if you speak Russian, POT is how you write up the word rot, which means mouth, and it's also how you phonologically pronounce the word pot, which means sweat. So now the Russian meanings of pot and rot are co-activated. If you're Romanian, that's the first person conjugation of the verb I can, and second plural for we can. So you can see that just one three-letter word shows all this spreading activation to all these other units in your mind. Think about this as, if you throw a pebble in the water, there are all these waves around the pebble, and the further you go out, the bigger the circle, and the closer you are to the pebble, the higher the activation. In the same way, the more overlap you have with the word, the more activated that word is in the mind. So why is this important? This is sort of the foundation, the mechanism that guides basically everything, the consequences that we'll discuss. Because bilinguals have to constantly juggle the activation of multiple languages, they have to constantly exhibit cognitive control on which language to use, inhibit the irrelevant language and facilitate the relevant language. It would do as little good if I would suddenly switch to Romanian, you wouldn't understand me. So it's important that I inhibit my Romanian, and you inhibit the other languages you know. Because of the bilingual brain's experience inhibiting language, we are now finding that this translates to advantages in inhibitory control beyond language. Executive function in general. Bilinguals tend to outperform speakers of just one language on many executive function tasks. They also perform better on language learning. If you are bilingual, it's easier to learn a third language than if you are monolingual. And with each additional language, it becomes easier to learn new languages. As you already saw, the visual search differs. What your eyes move to, what you pay attention to, differs depending on the languages you speak. In a way, you can think about what this means for how we process reality. We all think that we live in this objective reality, but the truth is that the reality that we each experience is subjective and shaped by our own experiences, previous experience, how we interpret any kind of interaction, and language is one of the key experiences that shapes the way we perceive reality. Our brain, the way our brain functions is changed by knowing multiple languages, and we'll consider some example of that. What we remember about ourselves, about the world, how we think about ourselves and the world changes as a result of knowing multiple languages. People who speak two or more languages often score higher on creativity tasks, and they actually make different decisions across their two languages. And of course, we can't go through everything, but I will take you through some examples of the kind of things that the bilingual brain performs differently on as a result of learning multiple languages. How many of you here are familiar with a Stroop task? Only a few. So this is one of the classic tasks to measure inhibitory control and executive function, cognitive control in the brain. Let's do it together. So what you'll be asked to do is name the color of the ink. I'll show you some stimuli from typical experiments, and just say out loud the color of the ink. Very good, keep going. Okay. Okay, so you see how it is a little bit more difficult, because in some cases, the color of the ink and the word coincide, and in other cases, they differ. So what your brains need to do is they need to pay attention to the relevant information and inhibit the irrelevant information. It turns out that bilingual brains tend to be more they tend to be faster at inhibiting irrelevant information in the Stroop task. And if you think, well, this is still a language task, we are reading written words, let's do something similar, but now no language is being used. So again, it's up to you to identify the direction of the arrow. If the arrow points right, you would be pressing the right key, so just say right. And then if the arrow points left, you would be saying left. So tell me the direction of the arrow. Very good, but you could see how in one case you have to inhibit the location of the arrow and facilitate the direction of the arrow. And inhibitory control is something that we use in just about everything we do. We are constantly having to inhibit irrelevant information and facilitate relevant information. As you listen to me now, you have to inhibit distracting noises, what your neighbor at the desk is doing, what you may be having for lunch later. You have to inhibit all those thoughts and facilitate information that matters when you are driving, when you are a sniper scoping a target, when you are a surgeon. You constantly have to facilitate and inhibit information. So of course we are talking about fractions of milliseconds there, but in brain time that's quite significant. Let's talk a little bit about the neural function, about what kind of changes do we see in the brain as a result of learning multiple languages. It turns out that from a very early age we see differences. And of course there are multiple variables that matter: at what age you've learned the language, how proficient you are, how similar the languages are. But one of my favorite findings in this field is the finding that the age of diagnosis for Alzheimer's and other types of dementia is on average 4 to 6 years later for people who speak 2 or more languages. So as a result of constantly juggling multiple languages, your brain gets so good at executive function that it can compensate functionally for the anatomic deterioration. It's not that the bilinguals' brains don't deteriorate, they deteriorate at the same rate. But bilinguals compensate functionally. And as you know, unfortunately, to this day, we don't have a treatment for dementia. There are multiple protective variables like exercise, education level, nutrition, literacy. But interestingly, the two variables with the strongest effect sizes, if you do meta-linguistic analysis of all the research out there, are exercise and bilingualism. And the effect sizes of the two are pretty much equal. Bilingualism, in essence, is like a workout for your brain. Your brain has to constantly juggle multiple languages. So there are many other things you could do as you age. You could do Sudoku puzzles. You could do Wordle. You could do lots of things. But the difference is you actually have to take time out of your life to do those activities, whereas if you're bilingual and multilingual, just by virtue of knowing multiple languages, your brain is constantly working out. Right now I'm speaking to you, your brains are inhibiting all the languages you know, facilitating this, and it happens all the time. And one way to think about this, the differences between bilingual older brains and non-bilingual older brains is imagine you take a certain road home every day. You go to work, you come back. You go to the store, to the pharmacy, wherever, you come back. You always take this road. One day, on your way home, you discover that that road has collapsed. If there are other roads that exist that you know about, you just reroute your GPS and you make it home without any problem. But if this is the only road you know, then you are in trouble. In the same way, in the bilingual mind, as a result of living a life through two languages or more, your brain has made connections, has experienced things, has learned things, had created memories in more than one language. So when one area of the brain deteriorates, the brain can compensate by relying on these other areas. Memory, so much to talk about there, but just to quickly tell you, not only do our eyes move differently, depending on what we see in front of us, but what we later remember to have seen differs as well. So if you are a Spanish-English bilingual and you have to look for a clock, you are more likely to remember that you've seen a clown and that you've seen a nail, a clavo. But if you're English monolingual, you're only more likely to remember that you've seen the clown. So the languages you speak influence what you remember seeing in a visual scene later, with implications for witness testimony, learning, treatment of memory disorders, lots of other things. Creativity, as I mentioned before, with connections to some of the things you've heard earlier about AI. We've started down this path. We've now done a few studies, including EEG studies, that show that bilinguals and multilinguals tend to make connections between things that others do not see. Of course, what is creativity? It's a construct that's hard to define. There are multiple components to creativity, but one component to creativity is being able to make connections between things that other people do not see. And just on simple tasks like how similar a few items are, or certain items are, and we run people through hundreds of trials, we see that bilinguals rate items more similar than monolinguals, items that are related and items that are not related. And since this is the Mandarin language conference, I'll just use an example that my PhD student presented in her dissertation defense as an anecdotal study, saying that when she goes to sleep, she counts goats instead of sheep. The reason she counts goats is because in Mandarin, the sign for sheep and goat share one of the two components, so she has this connection between sheep and goat. And there are lots of other examples that you may yourself have experienced. If you speak another language, you hear a word and it makes you think of other things and other things, and before you know it, you're on a completely different path of ideas and thoughts and creativity. And of course, I'm trying to get through a lot of things here. I do want to tell you a little bit about decision making, because with each language, as a result of these co-activations, different aspects of our identity come forward. Language is very tightly connected to culture, so language and culture together influence not only where our eyes move, but also the decisions we make on an everyday basis. So, for example, during the pandemic, we ran this study online asking people in either Mandarin or in English to make medical decision judgments, and we find that, for example, on some questions like how likely are you to challenge a physician or how likely are you to experience experimental treatments, Mandarin English bilinguals say that they are more likely to do so in their second language, English. And when asked how painful a condition was or how much distress they experienced, they are more likely to say that they experience more pain and more distress in their native language. In general, the native language is more tied to emotions, and the second language to more logical decision-making. One of my favorite examples on decision-making in bilinguals comes from the trolley problem. Some of you may have been familiar with the trolley problem. Is a very frequently used exercise used to study morality and ethics. And in this particular version of the trolley problem, the story goes something like this. Imagine that you are standing on a bridge above some train tracks, and a trolley is coming very fast right towards 5 workers. The trolley is about to run them over. They're about to die. You're standing next to a large person with a big backpack. If you push this person down, the person will die, but it will save the lives of these 5 people. My question to you is it permissible to sacrifice the life of one person to save 5? How many of you say, yes, it is permissible? Okay, how many of you say, no, it is not? So people vary in their decisions, right? There are multiple variables that you're considering. It turns out that if you ask people in their native language, about 20% say that, yes, it is permissible to sacrifice the life of one person to save 5. If you ask them in their second language, about 33% of people say, yes, it is permissible to sacrifice the life of one person to save 5. A 13% difference just by switching languages is quite significant. And those numbers change further depending on whether you are saying you're pushing a person or you're pressing a button. So people are more likely to say that they're okay with pushing a button than with pushing a person. Also, it depends how many people are we talking about. Are we talking about 5, 50, 500, 5 million? 5, I mean, you know, you can see how that could in science fiction have repercussions for how we think about AI and the future of the planet. But that's not the way I'm going to go with this. In the interest of time, I'd just like to wrap it up by saying that I hope you will remember that the bilingual brain co-activates multiple languages in parallel at all times. The constant juggling of multiple languages changes the way we think and the way we function in the real world, and has implications for just about every sphere of the human cognition and human function. The final note I'd like to close on is a study that surprised even me to reveal effects of bilingualism. Because again, monolinguals are all that's included in just about every field of medicine and science and everything else. How many of you know what spontaneous autoacoustic emissions are? Okay, so I didn't know this in the past either, but it turns out that our ears not only process incoming sounds, but if you put a highly sensitive microphone next to our ear, you can record the sounds an outgoing sound as well that our ears produce. These are called autoacoustic emissions. They've come relatively recently on the scene, and now there are autoacoustic labs around the world, a few here and there, trying to figure out what are these autoacoustic emissions? Why do mammals have them? We really don't quite understand. We know that they're there. We can measure them. We don't know what their function is. Is it something like the vestigial tail that's left? We don't know. And it just so happened that we have an autoacoustic lab at Northwestern run by Sumit Dar. So Sumit and I decided to just combine forces and test the autoacoustic emissions in bilinguals as well. Nobody had done that before, and we found out that the bilingual brain modulated autoacoustic emissions differently than the monolingual brains. It seems that there are top-down influences from the frontal lobe onto the autoacoustic emissions. To be honest, we still don't know why and how, and if that leaves you sort of confused and thinking, well, you just told me that my ears produce sounds and you didn't tell me why and then how, what I can say is welcome to science. This is how it works. You answer a question and you just open a lot more questions beyond that. And think about how many other questions we don't even know to ask, and how many mysteries known and unknown are out there that, because we don't consider bilingualism, multilingualism, and linguistic diversity, remain at this point unknown to us. So with that, thank you. I'd like to open it to questions, and it's sort of your chance. Anything you've ever wanted to know about bilingualism or multilingualism and didn't have whom to ask, I'm here for that. Thank you.